Hello, my name is Oliver Maiß and I lead the Research and Development Department here at ECOROLL AG. Today I have brought you an application example where I would like to show you how you can replace or partially eliminate processes like polishing through roller burnishing. We want to be mobile in old age. We might want to play soccer with our customers like the gentleman in the picture here and simply be mobile. And therefore, more and more people will eventually need artificial body parts like hip joints, knee joints, shoulder joints, etc. It is generally said that every third or fourth person will need an artificial joint at some point in their life. Additionally, these joints do not last forever, of course. That means a hip joint needs to be replaced every 10 years. We are getting older and older, and with that, the number of revisions is also increasing. Another case is that there are so-called mismatches. That means an operation is not always successful. Recipient and implant sometimes do not match, and the implant has to be removed again. And for this reason, because it is a very high risk, very high demands are placed on the quality of the joints. Using the example of a hip joint, I would like to show you a surface. When you connect the socket and the ball essentially rubs continuously on this socket. And that is, of course, the highly stressed surface, which eventually wears out over time. Here, the requirement is to have very low friction because increased friction naturally leads to increased wear. And then we have to replace the joint earlier. Low friction is achieved by having a very fine surface. This means we have an almost mirror-like surface, which is usually produced through a final polishing process. And here we have applied our roller burnishing process previously at our customers' facilities. The ball surface was produced through various polishing processes. That means the final process is polishing, which creates the surface, but now, of course, I can't just start with the finest polishing process right away. Otherwise, I would, so to speak, polish myself silly and would take an enormously long time to achieve the desired RZ value. So, the process is naturally carried out in multiple stages. I have a coarse polishing, a somewhat finer polishing, until finally reaching the finish, polishing, where the actual surface is created. All processes themselves take relatively long and are ultimately only there to set the correct roughness in the final process. We have now teamed up with our customer and tried to eliminate the entire chain. The goal was to completely eliminate the polishing process through smooth rolling and to create a mirror-like surface. You can see from the example shown here that unfortunately we didn't quite succeed, but we have eliminated all the preliminary processes, such as the coarse polishing and the finer polishing, and then only focused on the finishing process. This means we were able to produce such a smooth surface through smooth rolling that we could directly approach the components with the final polishing step. As components, we worked on ball joints, edited. These were made from a titanium alloy with very high strength and corresponding hardness. The process was carried out with a hydrostatic smooth rolling tool HG69, where the ball was rolled over the surface at a rolling speed of 150 meters per minute, and it had a feed offset of 0.1 mm. In terms of rolling force, we approached this relatively moderately with 750 N. The result for our customer was ultimately that he couldn't completely eliminate the entire polishing process, but he was able to eliminate parts of the polishing process and thus reduce his costs by 27%. And to mention the roughness value we achieved here, solely through smooth rolling, we reached an RZ value of 0.6 process reliable for all our components. With that, I sincerely thank you for your attention. If you have questions about this or other topics, feel free to reach out to me or my colleagues at ECOROLL AG